let's just talk about a speed limit, right? And let's say that we've got the fastest known moving thing, which maybe would be a photon, which is moving at the speed of light. And let's say that that's moving to the left at c, right? So that u is equal to, oh, actually, so u should be minus c. U should be minus c, sorry, because it's moving to the left. And let's just say relative to a moving reference frame, so that's relative to a stationary reference frame. Let's say that the moving reference frame rides with another photon at speed v, so v is equal to c, right? What is the relative velocity between our initial photon and our moving reference frame? Well, so that's going to be u prime. So u prime is equal to u, which is minus c, minus v, which is plus c, all divided by 1 minus v, which is plus c, over c squared times u, which is minus c. And so what do we get? We get that u prime is equal to minus 2c on top, c squared over c squared on the bottom, so that's 2, so that's minus c. Look at that. That is pretty interesting. If u is minus c relative to the stationary frame, u prime is also minus c relative to the moving frame. Wow. Still moving at speed c. Can't move any faster than speed c. Nothing can move faster than speed c. And actually, your frame of reference can't really move at speed c because your frame of reference really should be a massive object, not a photon. That's besides the point and comes up in other situations. Doesn't matter. It could be just a little less than c. So let's just do a real quick two-dimensional velocity transformation just so you can see it in action, although you should have the tools to do it at this point. Let's say that I throw a baseball in the, and I'm not showing me, I'm the purple frame. I throw a baseball to you in the unprimed frame. I'm in the stationary frame. I throw it at 5 meters per second at 45 degrees. You're running in the x direction at 3 meters per second. What is the velocity of that baseball relative to you? So you are the brown person that's running at 3 meters per second. That means that your frame of reference is the moving frame, where v is equal to plus 3 meters per second. If I want to know the velocity relative to you, I want to know the velocity relative to your frame. So again, you got to figure out what frame is what. And who, whether 3 meters per second is the velocity of a frame or the velocity of an object. 5 meters per second is the velocity of a frame or the velocity of an object. In this case, I told you that the velocity of the object relative to my frame was 5 meters per second. So now I want to find u prime. Now it's two-dimensional, so u prime x is equal to u sub x minus v over 1 minus v over c squared u sub x, and u y prime is equal to u sub y divided by gamma times 1 minus v over c squared u sub x. That's the velocity transformation. Let's just go back and check that out. Gamma 1 minus v over, yeah, okay. So that's the velocity transform. I don't know if I asked a question, but I just wanted to know if the velocity is 5 meters per second, 45 degrees relative to the unprimed frame, what is the velocity relative to the prime frame? So this is going to give us the velocity relative to the prime frame. So we can go ahead and plug in u sub x, right? U sub x is 5 meters per second. I'm going to leave off the units times the cosine of 45 degrees minus 3 all over 1 minus 3 over c squared times u sub x, which is 5 cosine 45. And I didn't plug in c because it's such a large number. And then u sub y is 5 sine 45 degrees divided by gamma. Gamma is the gamma. It's still just gamma 1. I mean, we can give it a number, 3 over c squared times u sub x, right? So although I made this so u sub x equals u sub y, but that's okay. Okay, so I just literally plugged in, and now let's just say, hey, in order to make this perhaps a tractable problem where the differences are noticeable, instead of making the speed of light 3 times 10 to the 8th meters per second, let's make the speed of light equal to, 10 meters per second. If the speed of light is 10 meters per second, let's go ahead and figure out what the velocity is in the prime frame. So we could have used 3 times 10 to the 8th, but I'm just using a number that's going to be easier to plug in, and this is the question we're asking. So in order to solve this problem, first thing we got to do is determine our gamma. Gamma is 1 over the square root of 1 minus v squared over c squared, which is 1.05 when I plug it into my calculator. And so now it is a plug-in, right? I'm going to plug the 1.05 in there, and I'm going to plug the c in to where it belongs. And so now it's just a plug-in, but I wrote it out so you can make sure you understand what variable is what. And let's go ahead and see what the answer is. So here are the results. The x component is 0.6 meters per second and the y component is 3.8 meters per second. Now, I want to compare that to what it would be under the Galilean transformation. In the Galilean transformation, the answer would be right here and right here, right? So the answer in the Galilean transformation would be 5 cosine 45 minus 3 for the x component, which is about 0.5, and would be 5 sine 45, which is about 3.5. So you can see that they're slightly different than they would have been in the Galilean transformation. Again, this was assuming c equals 10 meters per second. If c equals 3 times 10 to the 8th meters per second, and this was still done that where I throw you a ball, you're not going to notice the difference. But if we're moving close to the speed of light, you notice the difference. And then I could have asked, so those are the components, I could have asked for u to u prime in terms of a magnitude and direction. So we can go ahead and put those together. Say we have 0.6 in that direction, 3.8 in that direction. And you could go ahead and find this vector u prime and this angle theta. I'm not going to do that. Leave that as an exercise to the reader.